Welcome all. This is lecture on differential calculus. In this lecture, we will discuss introductory part and successive differentiation. So what is derivative? The derivative measures the sensitivity to change of one quantity to another quantity. That is, it measures the sensitivity to change dependent variable into the independent variable. If we have y equals to fx be a differentiable function in an interval ab, then d over dx fx is equals to f dash x, or it is equals to limit h tends to 0 fx plus h minus fx upon h. This is known as derivative or differentiation of fx. Note: the derivative of a function at a point x equals to c is the slope of the tangent to the curve y equals to fx at the point CFC. Successive differentiation. What it means? Successive means continuous, step by step. It means the process of finding the differential coefficient of a function again and again is called successive differentiation. If y equals to fx be a differentiable function, then d over dx fx can be written as f dash x or capital D of fx or y dash or y1. So these all are the notations by which we can denote differentiation of first order. Same as if we want to differentiate it again, then it will convert into d2 over dx square of fx. This can be written as f double dash x or d square of fx or y double dash or y2. Same as the third derivative can be represented as d cube over dx cube fx or f triple dash x or d cube fx or y triple dash or y3. Similarly, in this particular manner, we can write nth derivative of function fx as dn over dx raised to power n fx is equals to f raised to power nx or d raised to power n fx or y n time dash or y n. So this is how we can solve or how we can find the derivative of a function successively. If we have to find the derivative of a function, the fifth derivative of a function, then what we can do? We first find first derivative, then second, then third, then fourth, and then fifth. So this particular concept or this particular manner is known as successive differentiation. So based on the successive differentiation phenomena, we can write or we can prove some basic properties. Here we will prove some properties and some you have to prove. Property 1, find the nth order differential coefficient of x raised to power m. So how to find the nth order differential coefficient? We first let y equals to x raised to power m. So according to the successive differentiation phenomena, we have to first find first derivative, then second, then third, then fourth. then there will be a symmetry, and according to symmetry we can prove it. So the first derivative of it is y1 is equals to mx raised to power m minus 1. Now again we have to prove. So on differentiating again, then y2 will be m into m minus 1 x raised to power m minus 2. Again differentiating it with respect to x, then we get the y3, which is equals to m into m minus 1 into m minus 2 x raised to power m minus 3. Now see, it is m minus 1, then m minus 2, m minus 2, then m minus 3. So m minus 3, then m minus 4, m minus n, then m minus n minus 1. So according to this symmetry, we can write it as yn is equals to m into m minus 1, m minus 2 up to m minus n plus 1 x raised to power m minus n when n is less than m, or we can write it as nth derivative of x raised to power m is equals to m minus 1 m minus 2 up to m minus n plus 1 x raised to power m minus n. So this is the basic property or the formula for the successive differentiation. Here there is a corollary. If this m and n both are equal, then mth derivative of x raised to power m is equals to m factorial. On replacing n equals to m, then we get m minus 1, m minus 2, and it is 1. So the previous element will be 2, or previous is 3, and this is x raised to power 0, which is equals to 1, and it is m minus 1, m minus 2 up to 3, 2, 1. So which is the mth factorial. So property number 2, nth derivative of e raised to power ax plus b is equals to a raised to power n e raised to power ax plus b. This we can prove by the same manner by which we prove property number 1. So property 3, nth derivative of a raised to power mx is equals to m raised to power n into a raised to power mx into log a power n. How to prove this? By the successive differentiation, the first derivative of a raised to power mx is a raised to power mx as it is into m log a. Again when we differentiate it, then a raised to power mx as it is into m log a, and 1 m log a is already there. So m log a whole square, same as m cube log a cube, and m raised to power 4 log a power 4. So by the successive differentiation we can prove it. Property 4, nth derivative of ax plus b power m. So it will be m into m minus 1 into m minus 2 up to m minus n plus 1 a raised to power n upon ax plus b power n minus m. We can write it in the product also. If we take it in the product, then it will be ax plus b power m minus n. So we can write it in the denominator or in the numerator also. So how to get it? Again by the successive differentiation. So try it. Property number 5, nth derivative of ax plus b inverse is equals to minus 1 power n a raised to power n into n factorial upon ax plus b power n plus 1. So how to prove it? If we put m equals to minus 1 in the property number 4, then it will be minus 1 into minus 2 into minus 3 into minus n. So taking minus 1 from each the element, then it will be minus 1 power n, and from here 1, 2, 3, 4, 5 up to n. So it will be n factorial. This a raised to power n as it is, and m equals to minus n minus 1. So it will be n minus minus plus 1. So it is ax plus b power n plus 1. Now property 6. Nth derivative of ax plus b power minus m. So when we replace m by minus m, then we can get this minus 1 power m into m plus n minus 1 factorial upon m minus 1 factorial into ax plus b power m plus n into a raised to power n. The proof of this particular property is also the same of the property number 4. Now moving on to the next property, property 7. Find the nth derivative of sin ax plus b. So how to find y equals to sin ax plus b? So when we differentiate it first with respect to x, then it will be a cos ax plus b, or we can write it as a sin ax plus b plus pi by 2, because sin pi by 2 plus theta is always the cos theta. So again differentiating, so it will be y2 equals to a square cos ax plus b plus pi by 2. Again write it in term of sine. So again add pi by 2. So 1 pi by 2 is already there. So it will be 2 pi by 2. So when we have to find y3, then in the same manner this will convert into 3 pi by 2, and this is a cube. Then if we have to find the y4, then a raised to power 4 sin ax plus b plus 4 pi by 2. So from the successive differentiation, we can write yn as a raised to power n sin ax plus b plus n pi by 2. So this is the required formula of nth derivative of sin ax plus b. Similarly, we have a formula for the cos ax plus b. The only difference is from the property 7 and 8 is sin and cos. So nth derivative of cos ax plus b is equals to a raised to power n cos ax plus b plus n pi by 2. So we can prove it just like this. So property number 9. Nth derivative of e raised to power ax sin bx plus c. So till property number 8, we have all the functions in the single term. Now we have the product of the two functions, and which is very specific, exponential and the trigonometric, and in trigonometric it is a specific sine or cos. So nth derivative of this function is equals to a raised to power n r raised to power n sine bx plus c plus n alpha, and nth derivative of e raised to power ax cos bx plus c is equals to a raised to power n r raised to power n cos bx plus c plus n alpha, where r square is equals to a square plus b square, and alpha equals to tan inverse b upon a. And property 10, nth derivative of log ax plus b. This is equals to minus 1 power n minus 1 a raised to power n into n minus 1 factorial upon ax plus b power n. So these are the 10 basic properties of the successive differentiation. Now take some examples. Example 1. Find the nth derivative of sin 3x into sin 5x. So now let y is equals to sin 3x into sin 5x. Now see, we have all the formulas In the single function term, only we have property number 9, which is the product of two functions, but this current problem doesn't lie in the property number 9. So, to apply the successive differentiation, we first separate them by the addition sign or the subtraction sign. So, for this, we can write it as 1 by 2 into 2 sine 3x 5x. So, we are multiplying and dividing by 2. Now, it is in the form 2 sine A sine B. So, the formula of 2 sine A sine B is cos A minus B minus cos A plus B. So, when we apply this formula, then it will be cos 3x minus 5x. So, it will be cos minus 2x, and cos minus theta is always cos theta. So, it will be cos 2x minus cos 8x. Now, it is in the appropriate form where we can apply the property of successive differentiation. So, differentiating it n time with respect to x. So, yn is equals to 1 upon 2 nth derivative of cos 2x minus nth derivative of cos 8x. So, it is just like nth derivative of cos ax plus b. So, it will be a raised to power n cos ax plus b plus n pi by 2. So, what is a? A is 2. So, we write here 2 raised to power n cos 2x plus n pi by 2, and similarly here a is equals to 8, so it will be 8 raised to power n cos 8x plus n pi by 2. So, this is the required solution. So, next example, example 2. If y equals to sin rx plus cos rx, then prove that nth derivative is r raised to power n 1 plus minus 1 power n sin 2rx whole power half. So, to solve it, we can differentiate it directly n time with respect to x, because it is in the appropriate form where we can apply successive differentiation formula. So, nth derivative is a is equals to r, so r raised to power n sin rx plus n pi by 2 plus it is also contain r, so r raised to power n cos rx plus n pi by 2. Now see, this r raised to power n can be taken as common, but this is not in the form of which we have to prove. So how to solve it? We have one idea from the proof, that is the power is half. Here we haven't power half, but we can convert power half if we take square and square root, then the power half arises. So taking r raised to power n outside and squaring and taking square root here. So now it is a plus b whole square. So what is the formula? A square plus b square plus 2ab. So it will be sin square rx plus n pi by 2 plus cos square rx plus n pi by 2, and which is 1, and plus 2 sin rx plus n pi by 2 cos rx plus n pi by 2 power half. So 2 sin a cos a is the sin 2a. So we can write it as r raised to power n 1 plus sin 2rx plus n pi power half, because when we take this 2 inside, then 2rx plus 2n pi by 2, so 2 is cancelled out, so it is only n pi. So what is the formula of sin n pi plus theta? So sin n pi plus theta is the minus 1 power n sin theta. So applying this particular property, we get r raised to power n 1 plus minus 1 power n sin 2rx power half, which we have to prove. So this is the proof of this particular problem. This is a tricky problem, so we can say it is the important example So moving on to next example. Example 3. Find the nth derivative of e raised to power x sine cube x. So let y is equals to e raised to power x sine cube x. Now this is the product of two functions. One is exponential and another one is trigonometric, and which is specifically sine. So we can apply property number 9, but this contains power 3, and according to formula power should be 1. So first we have to make it unit. So how to make it unit? We can apply the formula of sine 3x here. The formula of sine 3x is 3 sine x minus 4 sine cube x. So from where we can get the value of sine cube x, and which is 1 by 4 of 3 sine x minus sine 3x. Or we can rewrite it as y equals to 3 by 4 e raised to power x sine x minus 1 by 4 e raised to power x sine 3x. Now this is in the appropriate form where we can apply property number 9. So differentiating n time with respect to x, so it will be yn is equals to 3 by 4 is the constant, so taking it outside, nth derivative of e raised to power x sine x minus 1 by 4 taking outside, nth derivative of e raised to power x sine 3x. Now see, in the first part, it is on comparing with e raised to power ax sine bx plus c. A and b both are unit. So the value of r raised to power n will be, the value of r square is 1 square plus 1 square, but we have to find the value of r, so it will be square root of 1 square plus 1 square. And on comparing this second with the standard form, a is equals to 1 and b is equals to 3. So nth derivative is equals to 3 by 4 as it is. R is the 1 square plus 1 square power half n by 2 e raised to power x sine x plus n alpha, and the alpha is the, we have alpha is equals to tan inverse b upon a, and here in the first case b and a both are 1, so it will be tan inverse 1 upon 1, while in the second case a and b, a is 1 and b is 3, so it is 3 by 1, and same as r can be replaced as 1 square plus 3 square power n by 2. So it will be 1 square is 1, 1 square is 1. So 1 plus 1 is 2. So it is 2 raised to power n by 2, and it is tan inverse 1. And it is 3 square is 9 plus 1 10. So 10 raised to power n by 2, and 3x plus n tan inverse 3. But we have the value of tan inverse 1. Tan inverse 1 is pi by 4, but we don't have the value of tan inverse 3. So we can put it as it is, and we can replace the value of tan inverse 1. So this and 1 by 4 can be taken outside from the bracket. So 1 by 4 e raised to power x is also the common. So it is 3 into 2 raised to power n by 2 sine x plus n pi by 4 minus 10 raised to power n by 2 sine 3x plus n tan inverse 3. So this is the required solution of the given problem. Hope you understand the entire content of successive differentiation. We will meet in the next lecture. In the next lecture, we will discuss Leibniz theorem. Thank you.